Combustion Engine, ICE, is a critical technological innovation that has shaped modern transportation and industry. It operates by combusting fuel within the engine to generate power, which is then converted into mechanical work. This script delves into the technical aspects of internal combustion engines, including their design, operation, and components. At its core, the internal combustion engine converts chemical energy from fuel into mechanical energy. The fundamental principle involves the combustion of a fuel-air mixture inside a confined space, producing high-pressure and high-temperature gases. These gases expand rapidly, exerting force on a movable component, typically a piston or turbine blade, thus generating motion. 1. Reciprocating engines. Spark ignition engines, SI engines, operate on the principle of the Otto cycle. They use a spark plug to ignite a pre-mixed air-fuel mixture. Compression ignition engines, CI engines, operate on the diesel cycle. They compress air to a high temperature and then inject fuel, causing spontaneous ignition. 2. Rotary engines, also known as Wankel engines, these use a rotary design to convert pressure into rotating motion. 3. Gas turbine engines, utilize the Brayton cycle, where air is compressed, mixed with fuel, and combusted. The expanding gases drive a turbine. 1. Cylinder block houses the cylinders where the fuel-air mixture combusts, typically made of cast iron or aluminium for strength and heat resistance. 2. Pistons, cylindrical components that move up and down within the cylinders. They convert the pressure of the expanding gases into mechanical motion. 3. Crankshaft converts the reciprocating motion of the pistons into rotational motion, which can be used to drive machinery or a vehicle's wheels. 4. Camshaft operates the intake and exhaust valves. It is synchronized with the crankshaft to ensure proper timing of the valve openings. 5. Valves. Intake valves allow the air-fuel mixture to enter the cylinder. Exhaust valves allow burnt gases to exit the cylinder after combustion. 6. Spark plug, SI engines, provides the spark to ignite the air-fuel mixture in spark ignition engines. 7. Fuel injector, CI engines, delivers a precise amount of fuel into the combustion chamber at high pressure. 8. Connecting rod connects the piston to the crankshaft and transmits the motion. Flywheel helps smooth out the power delivery of the engine by storing rotational energy. Engine cycles. 1. Otto cycle, SI engines, intake stroke. The intake valve opens and the piston moves down, drawing in the air-fuel mixture. Compression stroke. The intake valve closes and the piston moves up, compressing the mixture. Power stroke. The spark plug ignites the mixture, causing an explosion that pushes the piston down. Exhaust stroke. The exhaust valve opens and the piston moves up, expelling the burnt gases. 2. Diesel cycle, CI engines. Intake stroke. Air is drawn into the cylinder. Compression stroke. The air is compressed to a high temperature. Fuel injection. Fuel is injected into the hot, compressed air, causing spontaneous ignition. Power stroke. The expanding gases push the piston down. Exhaust stroke. Burnt gases are expelled. 3. Brayton cycle, gas turbine engines. Compression. Air is compressed in a compressor. Combustion. Compressed air is mixed with fuel and ignited in the combustion chamber. Expansion. The high-pressure gases expand through a turbine, producing power. Exhaust. The exhaust gases are expelled. Fuel types. 1. Petrol, gasoline, commonly used in spark ignition engines, provides a high energy density and relatively clean combustion. 2. Diesel, used in compression ignition engines, offers higher fuel efficiency and energy density compared to petrol. 3. Natural gas, can be used in both SI and CI engines, burns cleaner than petrol and diesel, producing fewer emissions. 4. Ethanol and biofuels, renewable alternatives to fossil fuels, can be blended with conventional fuels to reduce environmental impact. 1. Power. The rate at which work is done is typically measured in horsepower, HP, or kilowatts. 2. Torque. A measure of the rotational force produced by the engine, typically measured in Newton meters, Newton or pound-feet. 3. Efficiency. The ratio of useful work produced to the energy input is often expressed as a percentage. Higher efficiency indicates better fuel utilization. However, 4. Specific fuel consumption, SFC. The amount of fuel consumed per unit of power produced is typically measured in grams per kilowatt hours or pounds per HP hour. Emissions and environmental impact. 1. Greenhouse gases. Internal combustion engines produce carbon dioxide, CO2, as a byproduct of fuel combustion, contributing to global warming. 2. Nitrogen oxides, NOx, formed at high temperatures during combustion, contributing to air pollution and respiratory issues. Number 3, particulate matter. Fine particles resulting from incomplete combustion are harmful to human health and the environment. 4, hydrocarbons, HC. Unburnt fuel escapes into the atmosphere, contributing to smog and air pollution. Advancements and innovations. 1, turbocharging and supercharging. Techniques to increase engine power by compressing the intake air, allowing more fuel to be burned. 2, variable valve timing. Adjusts the timing of valve openings to optimize performance and efficiency across different engine speeds. 3, direct fuel injection. Delivers fuel directly into the combustion chamber, improving combustion efficiency and power output. 4, hybrid systems. Combine internal combustion engines with electric motors to reduce fuel consumption and emissions. 5, alternative fuels. Research into hydrogen, synthetic fuels, and other alternatives to reduce dependence on fossil fuels. The internal combustion engine, ICE, has been a cornerstone of modern technology, enabling the rapid advancement of transportation and industry. Despite the increasing focus on alternative energy sources and electric vehicles, the ICE continues to evolve with new technologies and innovations. Understanding the technical details of ICEs provides valuable insights into their operation, performance, and potential future developments.